3,000 light-years from Earth. The James Webb Space Telescope has revealed something in space that looks disturbingly familiar. At first glance, it looks exactly like a human skull, not a metaphor, not an artistic comparison. The shape is genuinely there. Eye sockets, a rounded cranium, and an eerie inner glow that almost resembles a brain inside a transparent head. Astronomers call it the Cranium Nebula, officially cataloged as PMR1. And once you see the image, it's difficult to unsee, because what you're actually looking at isn't a skull, that it's the remains of a dead star. And the story behind it is one of the strangest endings a star can have. To understand what the Cranium Nebula really is, we need to start with how stars die. Stars like our sun spend billions of years fusing hydrogen into helium in their cores. That fusion releases enormous amounts of energy, pushing outward against gravity and keeping the star stable. But eventually, the hydrogen runs out. When that happens, the balance breaks. The core contracts, temperatures rise, and the star swells outward into a massive red giant. During this phase, the star becomes unstable. Its outer layers begin to drift away into space, blown outward by powerful stellar winds. Unlike the spectacular explosions of supernovae, this kind of stellar death is slower and quieter. The star essentially sheds its skin. Layer after layer of hot gas drifts outward into space, forming a glowing cloud around the dying core. Over thousands of years, that expanding cloud becomes what astronomers call a planetary nebula. The name planetary nebula is misleading. Planetary nebulae have nothing to do with planets. Early astronomers simply thought they looked a bit like the disks of distant planets through small telescopes. What they're actually seeing is a star dismantling itself. At the center, the original star collapses into a white dwarf, a dense, Earth-sized remnant containing roughly the mass of the Sun. Around it spreads the glowing gas it once held together. The Cranium Nebula is one of these final stages. The central star is already gone, leaving behind its compact white dwarf core. The surrounding gas continues expanding outward, drifting across space at tens of kilometers per second. Over tens of thousands of years, that material spreads across light years of space. But what makes PMR1 so unusual is the shape that expansion created. For reasons astronomers are still studying, the gas didn't spread out evenly. Instead, complex interactions between stellar winds, magnetic fields, and surrounding material sculpted the nebula into intricate layers and filaments. When viewed in infrared light, those structures combine into something that looks remarkably like a skull. There's a rounded outer shell forming the cranium. Inside it, brighter structures form patterns that resemble a brain pressed against the inner surface. Dark gaps appear where you'd expect eye sockets. Our brains are incredibly good at recognizing patterns, especially faces and skulls. Evolution wired us to notice them instantly. So when a cloud of gas thousands of light years away forms a similar shape, the reaction is almost automatic. It feels intentional. But of course, it isn't that, it's just physics. And that's where the James Webb Space Telescope comes in. Webb doesn't see the universe the way human eyes do. Instead of visible light, many of its instruments observe infrared wavelengths, which reveal heat and structure hidden inside clouds of dust and gas. Using its powerful infrared cameras, Webb can peer through material that blocks ordinary telescopes. That allows astronomers to study the internal anatomy of nebulae in extraordinary detail. Filaments of gas appear like thin threads stretching across the structure. Some regions glow warmer and brighter, where gas is denser and closer to the central white dwarf. Other areas appear cooler and more diffuse as the expanding cloud spreads outward into the surrounding interstellar medium. In images captured in infrared wavelengths, these variations create the striking layered appearance of the Cranium Nebula. The colors seen in the images represent different wavelengths and temperatures detected by Webb's instruments. Together, They map the structure of a nebula in remarkable clarity. Planetary nebulae like PMR-1 aren't just visually striking objects. They are laboratories for understanding how stars evolve and die. When a star sheds its outer layers, those layers carry with them elements that were created deep inside the star during its lifetime. Carbon, oxygen, nitrogen, and many other elements essential for forming new stars, planets, and even life. Planetary nebulae are part of the cosmic recycling system. The material drifting away from a dying star will eventually mix with the interstellar gas of the galaxy. Over millions of years, gravity will pull some of that material back together, forming new stars and planetary systems. Some of the atoms in your own body may once have been part of a star that died billions of years ago. The Cranium Nebula is one moment in that enormous cycle. Planetary nebulae don't last very long on cosmic timescales. As the gas continues expanding, it slowly becomes thinner and fainter. The intricate structures begin to stretch and dissolve into the surrounding galaxy. After perhaps 50,000 years, the nebula fades away almost completely. All that remains is the quiet white dwarf at the center, cooling slowly for billions of years. Eventually, even that remnant will grow cold and dim. The skull-like shape we see today will vanish. The filaments will break apart. The glowing shell will disperse. And the atoms that once formed a star will become part of the galaxy again. That's part of what makes images like this so fascinating. They capture a fleeting stage in a process that lasts billions of years. We're seeing the aftermath of a star's life at a precise moment when its expanding gas happens to form a shape our brains recognize instantly. It feels eerie, almost poetic, but the universe isn't trying to send a message. The Cranium Nebula isn't a cosmic symbol of death. It's simply the beautiful, chaotic result of gravity, radiation, and gas interacting over enormous spans of time. Yet there's something strangely powerful about seeing it. A skull shape floating in space, formed by the remains of a star that lived for billions of years before our own sun was even halfway through its life. Somewhere out there, countless other stars are reaching the same final stages right now. Each one leaving behind glowing nebulae that drift across the galaxy brief, beautiful traces of a star's final breath. The Cranium Nebula just happens to resemble something we recognize. And thanks to the James Webb Space Telescope, we're seeing it with a clarity humanity has never had before. 3,000 light years away, a dead star left behind a cloud of gas shaped by nothing more than physics. And somehow, against all odds, it ended up looking straight back at us. If discoveries like this fascinate you, the strange, beautiful, and sometimes unsettling things happening across the universe, consider subscribing to the channel. Because the deeper we look into space, the more extraordinary the cosmos becomes.